Lesson 61 is about integration by guessing. Now that title of the lesson shouldn't come as a surprise to you because that's what you do when you integrate. You make an educated guess of what you think the antiderivative is based on what the function looks like. You check your work by taking the derivative of the antiderivative. In these problems you'll need to think a little bit more about your educated guess that you make because these functions will be a little bit more complex. To do these integrals, keep in mind some of your basic integrals that you've been working with, like the integral of x to the n. You know that that's equal to x to the n plus 1 over n plus 1. The integral of e to the x, you know that that's just equal to e to the x. The integral of 1 over x, that's equal to natural log absolute value of x. The integral of sine x, that's just equal to minus cosine x. And the integral of cosine x is equal to sine x. Use these basic integrals to help you make good educated guesses to evaluate these integrals. So look at practice problem A. Find the integral of that. Well, hopefully you see that power there, the fifth power, and hopefully that makes you think of a composite function of the form 4x squared plus 5 to the sixth power. So take the derivative of that. That would just be 6 times 4x squared plus 5 to the fifth power, then times 4 times the derivative of 4x squared, which would be 8x. That equals 48x times 4x squared plus 5 to the fifth. See, that did get us back to the original function. Therefore, 4x squared plus 5 to the sixth was a good guess. Usually these integration by guessing problems, at least right now, they'll be contrived problems. That means they're designed to allow you to just think of one of your power rules or a composite function rule like this and solve it pretty easily. Let's do another one. We have the integral of 5 sine to the fourth u cosine u du. Well, just think about that. Maybe that, hopefully, that looks like the derivative of a composite function to you. When you take the antiderivative, you always add a power. So let's just think about, or not add a power, just say increase the power by 1. So think about it like this. Let's guess sine to the fifth u. Think about it like this. Instead of sine to the fifth u, just think of it as sine u to the fifth power for right now. So we would have 5 sine u to the fourth power times the derivative of sine u, which is cosine u. So that does get us back to 5 sine to the fourth u cosine u. Sine to the fifth u was a good guess, so that's our answer right there. Sine to the fifth u. Now, one thing we're forgetting on these problems is the constant. On A, we need to put plus a constant, and on B, plus a constant as well, because that's the indefinite integral that we're calculating here. So even though we're focused on trying to guess the right integral here, we need to remember that it's an indefinite integral that we're solving for, so we add that constant on the end. Because if we take the derivative of that to get back to our original relationship, the constant equals, or the derivative of the constant equals 0. Let's do another integration by guessing x dx over the square root of x squared minus 5. Well, let's just rearrange this one first. Let's say x times, I never like to have them with a radical sign because we're always dealing with powers, not radical signs. And so let's get this in the form of x squared minus 5 to the minus 1/2 power dx. Now let's guess an antiderivative of that. We have a power of minus 1/2. Let's just think x squared minus 5 to the positive 1/2 power. So if that's our guess, take the derivative of that guess, 1/2 times x squared minus 5 to the minus 1/2 power, and then times the derivative of the inside function, x squared minus 5. That would be times 2x. And so that would simplify to x times x squared minus 5 to the negative 1/2 power. So that was a good guess there for that problem. And so there's our answer. And again, we need to remember plus a constant, because that's the indefinite integral. Let's go ahead and do one more. Find the integral of 5e to the 5 sine x times cosine x dx. Well, a good guess on this one, since it's a exponential function there, e to the 5 sine x, would just be to guess e to the 5 sine x for the integral. Take the derivative of that, and we would have e to the 5 sine x. Now that is a composite function, so then we take the derivative of 5 sine x and multiply by that. So that would be 5 cosine x. I'll just put that out front. 5 cosine x e to the 5 sine x. So that is the same thing. E to the 5 sine x was a good guess. Add plus c on the end. There's our indefinite integral. As with all integration, making a good guess of what the integral is, that's the best way to start. We're familiar now with some of our basic integrals like u to the n or x to the n, t to the n, whatever you want to call it. 1 over x, e to the x, cosine x, sine x. We're familiar with finding those integrals. Use what you know about the integrals of those basic functions to make good guesses on these integrals. Basically, these are integrals of composite functions. We could think of it like that. Okay, well that's all for lesson 61.